have a simple circuit that uses an independent source, as you can see here, a dependent voltage source, and then two resistors. Our goal here is to find Vx. So when we have a circuit, the first thing, always break it down. What do we know and what tools can we use to find the solutions to this? Well, we have one loop shown here. So we can do the voltage around that, which is KVL, Kirchhoff's voltage law. And we also have some resistors, so we may be using Ohm's law. So I'm going to write this down here. And we want to use these two different rules and try to make some equations and form this into a math equation. So what we're going to do first is go around KVL. And I'm going to start down here, so at this bottom node here. And we're going to go in a circle. And so we're going to go up this 25 voltage. And so we're going to write this over here. So we're going to go 25 volts from the voltage source. And then we're going to go up here. We can either, there's two different things that we could do. We could say, this is a resistor, so we can use Ohm's law to get that voltage. However, we see that this voltage source, Vx, is actually what is the variable that's measured to go into this dependent source. So we really want to get everything in terms of Vx in order to solve for it. I am going to take a little bit of a stretch and let's just use Vx as it's labeled, and we're going to come back and use Ohm's law later. So I'm going to use Vx here, and the polarity is drawn here. So we're stepping from this voltage to a higher voltage. So that's going to add the same direction as this voltage source. So we're going to be adding Vx here. Okay. Now we're going to go to this resistor, and we don't have a default polarity drawn here. So now we have to make a little bit of a step, and we're going to use Ohm's law to get this voltage. Remember that Ohm's law is, I'm going to write down here, V equals IR. But we don't have the current. So we do want to define a current, and we're going to have to assume a current. So I'm going to assume that the current is going this direction. And if you're not sure, you can just kind of guess. So we're going to guess it's going to go in this direction. So this is our I. And if the current is going in this direction in a resistor, that means that the current, the passive component, so it has to go into the positive terminal. So that means the voltage would be positive to negative here. So given that polarity, if we're continuing around KCL, that would then be now stepping down the voltage. So it would be minusing the voltage over the resistor, which from Ohm's law we know is I. We don't know I yet, but keep it as a variable. R, which is going to be 5 kilo ohms. And then we're going to step down one more time, this Vx divided by 4. And so we're going to minus Vx divided by 4. And we're going to make that all equal to 0. Okay, so we have two variables that we don't know in this equation. One is Vx, which we see twice, and one is I. So we need another equation that we can get from the circuit itself that has both I and a Vx in it. We already applied Ohm's law on the right resistor, the 5 ohm resistor, the ohm resistor. Now, can we apply it on this other resistor and get a relationship between I and Vx? Let's try. So let's just look at Ohm's law here. I'm going to assume the current is going in the same direction as the I. So the same I, it's going the same direction through the circuit. And when we do that to follow Ohm's law, the voltage polarity here has to be in this direction. So stay with me for a second here. So if I'm just writing the Ohm's law according to the 10 ohm resistor, we would write it as V10K equals I defined in this direction times the resistance, which is 10K kilo ohms. Okay, this voltage, that's the one where I drove positive to negative, that is exactly equal to Vx, but in the opposite polarity. So we can actually make this equal to negative Vx. And then we can take our two equations here from the KVL here and this side here. And these are independent equations. They have I and Vx in them, and we can now solve the system of equations to solve for Vx. If that helps you, you can stop the video here and just solve it on your own. If you want to go through and solve it, let's just do that real quick. So I would rewrite this bottom equation in terms of I and then put that into here. So we're going to put that I into here. I equals a negative Vx over 10k. And I'm going to drop the units here. And then we're going to write KVL and we're going to plug in the value for I here. So we're going to write 25, again dropping units, plus Vx minus, so now we have the I, so a negative Vx over 10k times 5k. Then we have minus Vx over 4, and all that is all going to equal to 0. So now you have one equation all in terms of Vx, and you can just simplify. If you want to watch me do the math, we can. Multiply this whole thing by 4. I think we'll simplify it. We'll get 100 here, plus 4Vx. Okay, the 5k and 10k becomes 1/2. Then we multiply that by 4, we'll get 2. Our negatives will cancel out, so it should be 2 plus 2Vx. And then minus, when you multiply this 4, it becomes just a Vx. That's going to equal 0. And so when we move this all together, we'll get a 5Vx on this side. So it's 100 minus 5Vx equals 0. We move that over. Equals 5. Oops. Sorry, this is a positive. Sorry, this is a positive. We'll move it over. Then we get a negative 5. I got a little ahead of myself. Vx, and when we divide through, we will get Vx is equal to a negative 20, and we'll add our units back, 20 volts. So this is our final equation here. And so what we'll see is this voltage negative Vx is going to be equal to negative 20. So it means actually this original polarity that we drew with the resistor is actually the correct direction. But we're assigning the Vx in the polarity given, that would be a negative 20. So our answer would be negative 20 volts for this. And the good thing about circuits is that you can go back in and plug this in. You're saying, is this really right? You can take this Vx, plug it into here. It'll give you your value. Plug this into here. If you redo the KVL and Ohm's law, they should all come out correctly. And then you know that your circuit is correct.